Hey there, 10-4 good buddy, and right now I'm looking at C is for Codewars, and yeah, it is from Codewars. It is a Python exercise. Yeah. C is for Codewars. Cool name. Cool exercise as well. I like it. So let's dig into what the heck it is. Build a string representing a capital letter C of a given size out of C characters. Let's take a look at this one. And this is an ASCII art exercise where given this function call and you supply a 1 as the argument, you're going to get this printout of a C. Yeah. And I think it's instructive to look at another example before I dive into the explanation. Let's look at the example when you generate with an argument of 2. This first one was with an argument of 1, and you take a look at it. Looking at it with an argument of 2, we see a little difference. So we see 2 full first rows, and then we have a bunch of rows with just 2 C's, and then we have 2 full rows at the end. You can kind of see a pattern here where for a given argument, it's got that number of full rows at the beginning and end. Like for an argument of 1, it's got a full row. It's got 1 full row at the beginning and 1 full row at the end of C's. For the argument of 2, it's got 2 full rows at the beginning and 2 full rows at the end. So, when you're having to generate ASCII art, you got to look at what are the patterns. So I see that pattern. Seeing another pattern is that when, or for the argument, the number of rows is going to be times 5 of the argument. So you have 1 as your argument. 1 times 5 is 5. You see there's 1, 2, 3, 4, 5 rows. There's 5 rows there. And if we scroll down, when the argument is 2, with this one, the argument's 2, we have 1, 2, 3, 4, 5, 6. Yeah, getting a little tedious here. 7, 8, 9, 10. So if we call the argument size, then the number of rows in your output is going to be equal to size times 5. And that is size times 5. This is an X. Yeah. But yeah, the number of rows in your output is going to be size times 5. So we see those patterns. We see the pattern of the, so if we call the argument size, we have a number of full rows that are equal to size at the beginning and end. You have these 2 blocks. And then the number of rows is equal to size times 5. Another pattern is in these interior rows, the non-full rows, the number of C's will be equal to size. Here size is 2. We have 2 C's per with these interior rows. So you're seeing a few patterns here, or at least I'm seeing a few patterns here. I don't know what you're seeing over there, but hopefully I'm doing a good job of explaining them to you. Yeah. And there's the exercise. So you got to really account for all of these patterns. And now I'm going to fire this one up, get it in the PyCharm, and let's go. Yeah, PyCharm will be good for this one because I can demonstrate the outputs as I go. And I'm going to be building a string to to satisfy this. So it's going to be, it really is going to be rows concatenated to each other. It's going to be, you know, generate this row, concatenate it, this row, concatenate. So it's going to be strings concatenated to each other. Of course, I'm going to need new lines at the end of each one. So like here, you're going to do a new line, here, a new line. So I'm going to concatenate the appropriate amount, new line, appropriate amount, new line, all the way down. This last one will not have a new line. The instructions actually say that, but I've glossed over the instructions because I gave my own. So I'm not going to look at them because we're already far enough in. So we will leave it at that. Home slices. That's a weird thing to say. Okay, so let's generate this sucker. And I'm going to call the final string final C to make it equal to empty string. And I'm going to create a variable to hold my size times 5. Because if you follow the pattern, you know a lot of this stuff is contingent on the size minus 5. So I'm going to go ahead and put it in a variable so that I am not continually multiplying the size times 5 in all of these different scenarios. It just makes sense to me to put it into a variable. And I'm going to loop. I'm going to use R for the row. And this loop is going to go really top to bottom. And I told you before, the number of rows total is going to be equal to the size the size times 5. So I'm making that my range. My range is going to be the size times 5, giving me the appropriate number of rows. In the body of the loop, I'm going to create the across portions of the row. I'm going to populate each row basically in a horizontal fashion. And I need to create a few rules to govern this, where you know, if I showed you before, let's take a look here again. That's not it. Yeah, told you before, like with looking at the one that has 2 of each. You have 2 full rows first, then you have the rest, then you have 2 full rows. So we're going to have 2 full rows according to size. We're going to have size full rows, if you can follow that. So I need to make that rule, and then of course I need to make rules for these other ones. And go back here. So I'm going to say if my number of rows, or actually my variable, is less than size, I am going to generate C's that are equal to the size times 5. These are going to be the full rows going across. And of course in Python you can multiply a string by an integer to duplicate it. So this is going to be full rows at the top. And for this next one, I'm going to do the condition of the interior rows, the rows that have a number of C's that is equal to the size. Actually, no, I'm not doing that one yet. I'm actually going to do the rows at the end because I like the way this condition is set up, or the flow here. So I'm going to do the end rows actually. The end rows is kind of complicated. I'll just type it up here. All right. All right, so what I'm doing here is I'm creating the bottom full rows. And what it is I'm going to say if r is greater than or equal to the size minus 5 times size, and it's less than the size times 5, then I'm going to populate a full row here. It's because when you look at the bottom, the ones on the bottom, what? Yeah. Whoops. It's a little hard to navigate, right? Yeah, looking at the ones on the bottom. Let's say, these are 10. It's 10 total, so, it's, size times 5 equals 10 here. 0, 1, 2, 3, 4, 5, 6, 7, 8. This would be rows 8 and 9. And what it is, in this case, size times 5 minus size is equal to 8. And while it's less than SZ, which is size times 5, it'll go 8 and 9, covering these two spots. So not a full explanation, but maybe you can follow what's going on by me plugging in the numbers for when the size is 2. It's gonna go for 8 and 9 while it's less than 10, and it's gonna do a full row for those rows. And yeah, so these are the ones at the bottom. All right. And then otherwise, you're doing the interior rows. And the interior rows are just going to be, it's going to be plus equal C times size. This is going to be the size given as the argument. Like if the argument is 1, you're going to have 1 C in the interior rows. If the size given is 2, you're going to have 2 C's in the interior row. And sort of finally, after each row, the if, elif, and else, these each create single rows at a time. And after each single row, you're going to have to put a new line. So I'm going to do that. And of course, I don't want a new line at the end, and there's a better way to handle this maybe, but I'm going to do the kind of the cheap duct tape way, and I am going to strip it at the end instead of creating a condition or such. I'll just strip it at the end so that the last new line is just stripped out. And there is your ASCII generator. Let's take it for a spin a little bit here. And yeah, I didn't explain some things fully in the interest of time. So I was rambling enough, I think. So, but you guys can get it. Okay, let's look at the C we've generated. Beautiful, beautiful, beautiful. You see we got 2 corresponding to the 2. And then we got 10 total lines. Then we have 2 on the interior, 2 C's. So 2 rows to begin, 2 in the interior, and then 2 to end. Let's do 4. The big C. See, we have 4 full rows at the beginning. Then we have interior rows, as I call them. You have 4 C's, and then you got 4 rows of full C's at the end. All right, we'll do 1 as a last one. Okay. Yeah, 1, 1, 1. It's all good. So I'm going to plug this in, and let's go with it. Hallelujah. Plug it in, plug it in. Let's get it. Alrighty, that looks good. And folks, there we go. Impressive, impressive. I know it is. You know it is. All right, y'all find a better way to do it and let me know. And but for me, I got my solution, so I am out.